So, been a bit overdue to do a video on the alternative that I've come up with for close coupled T's at the manifold. Now, to be fair, I've not tried this, but I can't see any reason why it shouldn't work. And if anyone wants to give it a go and give us some feedback, I'd be very grateful. I do think it's going to work. Now, this does really come from an amalgamation of stuff from Wiesmann and Kalefi as a workaround. I still think it's a bit of a workaround, to be honest. It's not going to work perfectly, but it'll be a lot better than a short circuit, as I've been calling it. So first of all, to stop the overloading or over pressurization of the manifold, spring bypass, the standard system we've been using for a long time. So if our mixing valve is closed, there's no call for radiators to ease the pressure from the pump. No path for the water, opens the spring bypass. This can be set up correctly, so we get a backflow to the boiler to let the boiler know that it's not wanted. That water going back will cause the boiler to basically switch off. It'll see there's no load, and that's without overheating and without deadheading. That's to be fitted before the zone valve, obviously, because when the zone valve closes, we may need some balancing effect for the radiator circuit if there's TRVs on it. If not, then the spring valve won't operate anyway. Next is a flow setter. Now the flow setter should be adjusted based on the load of the underfloor at DT20, not at DT7. And this is to make sure that the pumps here can't demand from the boiler more than the flow that the boiler can provide. So it's not the same as decoupling it, but it should stop the effect of drawing water from the radiator circuit. So in effect, you'll still get the correct flow, the correct balance through the radiators, or close to the correct flow. You'll still get a loss of flow there, but it's going to be far less affected when this valve opens. Far less affected. Now the other thing that happens is that we get a situation where we have this flow controlled here, and basically the system wants a higher rate of flow. So this valve could be fully open, for example. This is restricting the flow to the system. So basically it can come back through this system here, which is a flap type non-return valve. So basically we'll get the backflow that we want here. So there'll be no problem between these two. And that will be recirculating the water that does go back to the boiler. Well, the problem is the boiler can't see this recirculation process going on, so it doesn't know that load's there. But either way, as I say, it's not perfect. Really, we need hydraulic separation at the boiler for it to work properly. And I know a lot of people are struggling with the concept of the boiler seeing the load. But this is a far better compromise in my opinion, but it's still a compromise. If you've got no choice and all you've got to do is fit these extra items in here. So this is already going to be there. So it's a spring-loaded bypass. And don't forget, this can go at the boiler. It doesn't have to be down here. It can go at the boiler anywhere on the system. As long as it's before that motorised valve, doesn't matter where it goes. So find a spot to put in the spring bypass if there isn't one there. You've got to find room for the flow setter. That's basically your close coupled T, but with a non-return valve in it. And that's it. So far less of a compromise, but still a compromise. I hope that's helped.